And get going. So, hello everyone. My name is Brad Cloth. I'm the manager of solution architects for Wordscape North America. I just wanted to say welcome to our webinar today, Embrace the Future of Data Management with Automated Cloud Data Warehousing. And so today in this webinar, we'll be talking through the history and evolution of cloud data warehousing, touching on the importance of automation as an aspect as you embark on this journey of building out your data warehouse in the cloud so that you can more easily meet the needs of today's users who, of course, want their data bigger, faster, and more insightful than ever before. Leading us today will be our guest, Mike Ferguson. He is the Managing Director for Intelligent Business Strategies Limited. Mike's been in IT for over 40 years, so he's an expert on BI, analytics, data management, big data, enterprise data architecture. The list goes on and on and on. So we're very happy to have Mike here with us today. Before we get started with him, there's one housekeeping item I wanted to mention. If you have any questions during the session, you'll see down at the bottom of your screen to the left, there's a little Q&A button. If you click that, you can type in your questions and we'll gather them all up. And then after Mike's presentation, we will have him answer them for everybody. And so with that, Mike, I will turn it over to you.
Okay, thanks, Brad. So good morning, good afternoon, good evening, everyone, wherever you may be. Many thanks for taking time out of your schedule to join me today. So I'd like to discuss really, where we're headed with data management and automation in the context of cloud data warehousing. And um, thanks for the introduction, Brad. If you need to know a little bit more about me, you may know I also co-founded a company called Cod and Date many years back with Turing Award winner Dr. Edgar F. Cod and Chris Date. Cod, of course, invented the relational model, which caused the birth of the SQL language and relational databases. And then I went on to Teradata. And back in 1992, over 30 years now ago, I formed my boutique industry analyst firm. I'm based in UK, so I'm speaking to you from across the pond if you're in the US. And you may know me as chairman of Big Data London, which is the largest data and analytics conference in Europe with over 20,000 delegates. So what I want to do is tell you about or talk about, let's say, where we are, at least for a lot of my clients as an industry analyst and consultant, look at where we are in terms of analytical data stores and look at the issues that are associated with that and why companies are turning to the cloud to build data warehouses, either to build from scratch or to migrate over there. And there's new requirements associated with that in order to exploit all of the capabilities that are appearing often on the cloud first before they become available these days on premises. So then we'll look at a contrast, which is data warehouse versus lakehouse, and what what the difference is there. And I want to explore that a little bit, talk about lakehouse open table formats and the impact that that's having on data architectures with respect to data warehouses and what it means in the future. And is that a good thing or a bad thing that lake houses are around? And how could we potentially take advantage with data warehouse automation or look at how data warehouse automation works? But how could you also use it in the context of what we've already discussed prior to that, particularly around accelerating data warehouse development using open tables? And I'll explain what those are when we get there. Again, please feel free to ask any questions, and we'll hopefully get to them before the session's out. So let's first of all just start looking at where a lot of my clients are at. I think most organizations that I work with in general, they've got multiple different kinds of analytical data store. Of course, the classic data warehouse, as you can see, there's one right in the middle of your screen there. That could be on premises for a lot of companies, could be multiple data warehouses. Several of my clients have multiple data warehouses. There are also data lakes, which typically these days are cloud storage, often used for data science to build machine learning models, and more recently, sort of generative AI use as well. Um, we have special purpose databases like NoSQL graph databases, which are not relational and have proprietary query languages, but they are often optimized for very specific kinds of analytics, for example, fraud or cybercrime. And then last but not least, on the left-hand side, we have real-time streaming analytics, which is often done for example, for industrial IoT in manufacturing or pharmaceuticals, could be logistics and supply chains and things like that. Also could be for consumer IoT, where you're monitoring product usage after products have been sold because they've got various sensors in them that you can collect data from, or it even could be things like monitoring live streaming data from clickstream on your website as people navigate your website, or even things like external financial markets data. But for most of my clients, we got all of these going on, not just, one or some. Most of my clients have got all of this stuff going on at the moment, pulling data from a range of different data sources. And so what's actually ended up is yes, they've got data warehouses, and increasingly now looking to the cloud. Now, if you're concerned, well, is your data warehouse database running on the cloud? The answer is almost certainly yes. Almost every major data warehouse database vendor, as you can see here, looking down this list, all run on the cloud today. So it's not like you would be struggling to find that kind of analytical relational database system running over there. But there are issues with multiple analytical data stores today. A lot of my clients are still operating in silos. That means that, the folks working on data warehouse are not the same as the folks who are working on graph databases, and are not the same as the folks doing data science or streaming analytics. And yet all of these kind of silos here require data integration. And often there are multiple tools being used. So tools being used for data integration to populate data warehouses and data marts are often not the same as the tools being used for graph analysis to populate a graph database, or perhaps for data science to engineer data as input to machine learning models and whatnot. So you often find that there are people kind of operating within their silo, unaware of what's going on in other silos. And you often find that there's a range of different tools out there across all of these to do the same thing, which is to connect to data sources, capture data, clean it, integrate it, and make it available either to store or even for real-time analysis. And with no industry standard, the chances are that people in one silo are totally unaware of what people are building in another silo, if those people have a different tool to the ones that they're using for data integration. So there's no industry standard to share metadata like that between tools, to be aware that maybe someone has already reinvented this. So quite frequent in a siloed environment to see this point-to-point building of pipelines. So the data integration pipelines are pulling data from a range of sources for a single purpose, for a specific machine learning model to be built in data science, or to populate a data warehouse, or to populate a graph database. I mean, that's it. I mean, that's what we built the pipelines for. And frequently the same data sources, often used, or certainly overlapping data sources used, where there's some of those data sources that where you take the same data for different analytical use cases, which means we're reinventing and possibly even inadvertently transforming the same data differently in different pipelines, when perhaps we would prefer not to. So there can be inconsistencies caused by this kind of sort of single purpose data integration approach on siloed analytics. Of course, if you just hand out self-service data prep to business users, which we did probably 10 years ago now, and we even have it baked into all the BI tools, you'll find that we got a wild west, everybody kind of grabbing data themselves and doing their own thing and kind of getting a bit of chaotic situation and losing control of the situation. One of my clients used a phrase that everyone's blindly integrating data without any attempt to share what they create. And that can lead to even more silos, of course, if everybody's doing their own thing and inconsistently, again, potentially um, creating, different versions of the same data, and that results in inconsistent results across different analytical tools and whatnot. So, if that proliferates and gets progressively worse, people can question this and say, well, look, how many times are we engineering the same data again and again? And is this going to lead to multiple versions and inconsistencies and potentially garbage in, garbage out, so to speak? We don't want inconsistencies. We want confidence and trust in the data that we use. And we prefer to not continually re-engineer it repeatedly for different purposes when we could do it once and reuse it everywhere. So I guess the picture on the left is kind of where a lot of my clients have been when it comes to engineering data. They've got people, doing their own thing in their own silo, and therefore potentially multiple versions of the same data being created, but people can't really tell because they can't see across tools. There's nothing organized, and so if they can't find the data anywhere, that they'll just go and build it, and even if it's been built somewhere else with some other tool. Whereas most of my clients really want the picture on the right, which is reusable, organized data products that they can pick up and reuse. Now, what's all this got to do with cloud data warehousing? Well, I mean, obviously, increasingly now, more and more workloads happening over there in the cloud. There's all kinds of business and technical reasons why you'd want to go there. From a business reason perspective, this shifts you away from capital expenditure where you have got to buy your own kit and set up and install everything on premises to operational expenditure. And so therefore, more of a pay as you use kind of model, which a lot of CFOs like. But in addition, it could be that you're reaching the capacity, of an on-premises system, and therefore you're at a point where a new project has appeared, and you really don't want to go out and spend a huge amount of money on a hardware upgrade, and so that's another reason for driving it, or some kind of event occurs. For example, a couple of years back, IBM announced end of life on some of their Netezza systems, which triggered a kind of shift to the cloud for a number of those clients. Yeah, of course, cheaper cloud storage. And of course, recently you probably noticed that several of the cloud service providers have dropped their egress charges now. So no longer charging um, egress charges to take data off of their clouds or move it between clouds. And of course, the administration activity, or a lot of it's taken away. You don't have to worry about installing software and all those kinds of things. It's taken care of for you. Therefore, you can kind of get up and running much more rapidly. On the technical side, I mean, again, besides the lower storage costs and being able to kind of scale on a more elastic basis, there's also maybe several of the data sources that you already have already out there on the cloud. People want to exploit other kinds of services such as machine learning and generative AI, which are being released on the cloud first, and they want to use that with the data that they have in data warehouses. These are all kind of drivers for people wanting to go over there, and to decouple storage from compute so that you can again toggle those independently, um, and be able to take advantage of uh, you know, independent elasticity. But for most of my clients, we've got some hybrid setup. Maybe they've got some data warehouses over in the cloud. They got maybe another one on premises, and we'll be living in a hybrid world for a number of years yet, I think. So, but what we've also seen in the cloud over the last few years is the emergence of lake houses. And lake houses are kind of different from data warehouse. Data warehouse, typically it's a centralized architecture still on the cloud. It's typically a scalable relational database where you ingest data into that. The data is typically stored in proprietary table formats, although it does several of vendors now supporting open table formats, which I'll get to in a second. Um, and you can separate storage from compute. So an example here would be Snowflake. And here you can see an architecture for Snowflake, actually, where you can see the storage along the bottom and different compute clusters, which are sometimes referred to as virtual data warehouse or virtual warehouses, which allows you to run different things in different clusters. You can run complex queries in one cluster and simple ones in another, and ELT in another, and not have them bump into each other. But still primarily data warehouse workloads running on there, although they can often start to handle other more complex data, but often by running the analytics outside of the database. And probably back around 2021, 2022, we saw a lot of data warehouse vendors talking about cloud-based integration, cloud data warehouse vendors integrating with cloud storage and using external tables. I had some issues with that, though. I mean, it meant there's still no what I would call ACID support, which is really the properties for transactional integrity, which means that other engines could come in and just kind of like update the data without you knowing about it, and therefore wreck the integrity, change the schema and stuff like that, and therefore that's not great grounds for getting trusted data to produce insights or even to build machine learning models. And so there was also a few question marks on lots of concurrent users using data that's in cloud storage simply because there's no optimizer down there. I mean, it's just straight file system, and so you're kind of at the mercy of the file system, albeit that we can have columnar file formats like Parquet and whatnot. But this is kind of centralized architecture. Now, lake houses, on the other hand, weren't just files in cloud storage. This introduced much more sophistication than that, a more metadata layer over the top, the introduction of open table formats, and examples of open table formats shown here like Delta Lake or Iceberg or Hoodie. They're not the same as proprietary tables that you would find in classic relational databases. They're open. That means that multiple engines can access them. But in this case, ACID properties are guaranteed. That means data is remaining consistent despite that going on, and that you can do other things like govern schema and whatnot on here and allow the support of other BI tools and other data engineering tools. So it kind of moves you beyond just exploratory analysis like you would see in data science into being able to support, highly integrated, good integrity data, which could support both data science and BI workloads. An example of that being Databricks, but there's plenty of other lake houses out there. Watsonx.data, for example, Cloudera, and many others. But I did want to point a few things out again. As I said, difference with open tables and proprietary tables is I can have multiple engines update the open tables at the same time, not just the database engine. And transaction integrity is guaranteed, which is very important for building machine learning models and for producing BI. I can support streaming at the same time as batch, and therefore I can land live streaming data straight into these open table formats. I still get to be able to do compressed columnar file formats like in data lakes, and I can do hidden data partitioning, which gives me more parallelism, which is better performance than classic just raw data lake with no kind of smarts over the top of it. But just to explain the difference, open table formats, like you see on the left, versus proprietary table formats on the right. You can see here, for example, a data warehouse database on the cloud, like BigQuery, for example, supports open table formats, but other engines can access it at the same time. Whereas if you're using proprietary table formats, only the database on its own can support and access that data. So here's an example from BigQuery. You can see accessing Iceberg tables. And just today, in fact, I added this to the bottom of the slide because this morning Google announced that they can now support Spark stored procedures in their data warehouse database. which allows you to run analytical stored procedures in the database. So more convergence going on here on open table formats. But just if you look over the last year, the activity around database and data warehouse vendors supporting open tables has exploded. So you can see several of the popular data warehouse vendors, whether it's AWS with Redshift or um, Google with BigQuery or IBM with DB2 or Netezza or Snowflake or Oracle or Microsoft or Teradata. They're all announcing support for open table formats, which is kind of interesting. So in a way, what we're now saying is, yes, we have the ability to bring together and integrate lakehouses and data warehouses. It's not warehouse replaced by lakehouse. It's like the two are morphing. It's integrating. We've got, as I said, asset support, which is very, very important for a BI and machine learning and AI. We got better performing SQL queries because we have things like partitioning and whatnot, columnar compressed file formats. We can handle schema change, we can handle history and more. So this is kind of interesting. And I guess what's happened is this diagram is kind of slightly different from what you saw a moment ago. So now you got data warehouse integrated with lakehouse. But the difference is now within the warehouse, I can either have external tables pointing to open tables, or I can have native open tables in the data warehouse itself, whilst at the same time allowing other engines like Spark or Flink or Presto to be able to go and access that data and even update it at the same time whilst maintaining integrity of the open tables. Now you might say, well, why is that interesting? Well, it brings together these two worlds. Not only that, but federated queries now going into data warehouses, so I can put those open tables across multiple clouds. And in fact, in IBM's case, they said not only multiple clouds, but on-prem as well, so that your data warehouse could connect to open tables across multiple clouds and on premises. And so ultimately you could create data products here, which would then be available to multiple analytical engines in a federated architecture. Personally, I think we're going to go further. We're probably going to see some control plane over the top trying to control multiple engines, maybe even new versions or new kind of optimizers appearing to decide which engine to run different analytical workloads on. But if that's where we're headed, and there's no question that I've seen significant announcements here. What does it mean for automation? Well, data warehouse automation's been around for many, many years now. This is just the definition of data warehouse automation from Wikipedia. And we've been using it obviously to accelerate our ability to build data warehouses, shorten the time, if you like, it times, to build it and hopefully, make it more rapid to kind of put that together. And the scope of data warehouse automation varies. I mean, you can use it for just building a data warehouse. You can use it for just building data marts. You can use it for building data warehouses and data marts. In some cases, for BI tools that have semantic layers, you may get the ability to generate the semantic layer as well. Or, you could have complete automation of everything kind of end to end. And the way these kind of tools work is it's very much dependent on metadata. So, of course, metadata includes things like the logical and physical data models of your target systems, whether that's data warehouse or data marts. It's the metadata associated with the sources, which are the schemas, if you like, of the physical schemas of the data sources. There's metadata associated with cleanup and transformation of the data and integration of that data, to say how that should work in order to populate the data warehousing environment. And there's the semantic layer to give more business-friendly data names to the data within front-end BI tools. Now, all of that's metadata, but data warehousing automation works by effectively keying that metadata into the data warehouse automation tool, and then using the tool to generate the schemas for your data warehouses, data marts, to generate the ELT processing to populate your data warehouse, data marts, and in some cases generate the semantic layer for BI tools, for those BI tools that have them. And you can reverse engineer sources. You can even connect into popular data modeling tools, or tools like Wordscape have their own data modeling capability as well, to be able to design your target environment. And you might say, well, why is this useful? Well, it's not just useful for the initial build. There's also change management, which of course can be a killer on a kind of older style waterfall data warehouse architecture like this. If I added a schema change on my data warehouse, that could impact the jobs populating the data warehouse, but it could also impact downstream ETL jobs going to data marts. Similarly, if I changed the schema of a data source or added a new data source, then that could ripple all the way through this waterfall architecture and require changes all the way through it. So cause lengthy amounts of testing to make sure everything works okay. So you get this kind of domino impact in that kind of waterfall architecture. Now, clearly, that can be quite complex to figure out and test, and it's often why people end up with a backlog and struggle to get over it. Now, if you take something like a schema change to say a sales data warehouse, and here we've got country-specific data marts, uh, that schema change could, if that data is also carried forward to individual data marts, could snowball right through everybody, and then so they need to make changes all the way through all of the data marts that data is used in. And if it turns out that a company's got multiple data warehouses, then yeah, if that same data is needed in another warehouse, this schema change could actually spill over into other warehouses and cause the same kind of problem there. And so you get longer and longer testing and retesting to make sure everything's okay, whilst the business is screaming for even more change requests. That's really for me where data warehouse automation really pays dividend. A lot of people focus just on the initial build, which of course is automated by providing the metadata, but it's the change management which is a real key benefit as well, because I can then make the changes in the metadata, and the tool knows precisely what has to get regenerated, as opposed to a complete rebuild of everything. It's just making the necessary incremental changes that are needed in an automated fashion, and so should guarantee and shorten the time it takes, to make those changes and get them deployed and up and running much more rapidly. So having discussed kind of what's going on in data warehousing and kind of the move to the cloud, the convergence between data warehouses and lake houses, and the use of open table formats, and then we've talked about data warehouse automation, I wanted to say, okay, now, well, how does this apply then? If data warehouse automation is being used to accelerate cloud-based data warehouses, what happens if open tables are in play? Well, this takes me to the world of data products, which has been given a lot of hype and a lot of, I guess it's been popularized by the emergence of data mesh back in about 2019, I think it was. The ability to produce data products rather than build a monolithic model, if you like, for a data warehouse and then populate it. Could we just build data products and then assemble those, for example, to use in data warehouse or to use in other kinds of analytical workloads? One way to do that is to create a data concept model. It's not a logical data model of any detail. It's a data concept model where you'd work with a business, and then for each data concept within the concept model, you'd start the definition of your data products in a business glossary within a catalog. These days, you will find business glossaries are actually part of a data catalog. So for every concept in the data concept model, I can start to create the data product, the data entity within the business glossary, and then get subject matter experts to kind of build that out and decide all the business data names for the attributes that are associated with those individual data entities, whether it's customers or orders or whatever it happens to be. And so get that defined within your business glossary in a catalog. And then having done that, we can then decide a schema for my data products and then build pipelines to produce the data products. And then from there, we can consume the data products and use them for data warehouse. We could use them for uh, data science and other use cases. I see there's a couple of questions and hands being raised. If you'd bear with me, I'll um, like to take those questions towards the end of the session. But the whole idea here is very different. We're not building pipelines for a single analytical use case. What we're now doing is building data products. And the data products are available to support multiple analytical workloads. In other words, build them once, reuse them everywhere. And as we start to see the convergence of and the merging or tearing down of these silos, like let's say, well, what happens if we could put these in open table format? Well, what we've already learned about open tables is that they are available to multiple engines, whereas in the past we would have one data store for every engine. Now we've potentially got the ability to have multiple data stores, to have open tables available to both data warehouse and other engines. So you could build reusable data products, store them in open tables, and then as we converge and modernize our architecture, we're still okay here to support multiple analytical workloads, even if you are reducing the number of data stores and creating integration between your lakehouse and your warehouse, which means that automation could potentially create the pipelines to produce the data products in open table formats for each of the data products defined within the catalog. And so therefore automate the pipeline development, build the data products, put them in open table formats. And then we know already that those open table formats can be accessed by data warehouse databases and other analytical engines that we use for data science and whatnot. So the idea is that we're getting rid of these silos. The benefits of using data automation to provision data products in open table formats is that we build them once, we have them in open table formats, which are available to multiple engines, whether that's a warehouse, whether it's Spark. And one thing I haven't mentioned, you may or may not have noticed that June last year, we saw the addition of something called property graph queries to the SQL standard, an extension to the SQL standard to do graph analysis in SQL, bearing in mind that open tables, of course, can also support streaming. So what we get is potentially something like this. We already know that warehouse and lakehouse can integrate. So you could potentially, therefore, with data warehouse automation, build these reusable data products. And then you can say, well, okay, I can access these open tables from my data warehouse. So I pick the ones I want to form my data mart and go ahead and start producing BI from it. Whilst at the same time, I can make those open tables available to other engines, including Spark. And if you took what I said about Google BigQuery that announced today that they just can now run Spark store procedures in the warehouse, then yeah, you could even merge that into there too. So, what we're getting is this kind of convergence and the ability to build once and reuse everywhere. support multiple analytical workloads. And so what you get is warehouse automation potentially able to build data products in open tables, but we know already that federated query support is possible. So, and we know multiple engines can access those open tables. And so, yeah, you could potentially build data products across multiple clouds and even on-prem, in IBM's case. But given that we can access those open tables directly from within the data warehouse, then uh, it's accessible. It's not like I have to create another copy of the data. I could, I suppose, if you want, bring the open copy the data into proprietary table formats. But as more and more data warehouse vendors support open table formats, then you have to say, well, at what point are we going to see are we going to see a number of proprietary tables start to diminish and more open table support being used in warehouses? But what we now have is a federated architecture. Building data products once, reuse them across multiple analytical engines, Spark, Flink, um, data warehouse, etc. Without necessarily having these different silos that aren't very well integrated and without having to repeat the integration for every silo. So I guess what we end up with then is kind of that, most companies have multiple silos, these analytical data stores. And we know that the number of data sources is growing rapidly, but we also know that beyond just data lakes, we've seen the emergence of lake houses. And lake houses have introduced open table formats. I guess Databricks was first with its Delta Lake open table format, but now we have Apache Iceberg, which I think came out of Netflix, and we have a Hoodie as well, and sort of three open table formats, which I think the differences between those will kind of get ironed out pretty quickly over the next year or so. But the key point is that we're seeing mass uptake by data warehouse vendors to be able to access the data within open table formats. And that those open table formats give us the ability to share data across multiple analytical workloads. And so by creating data products that are reusable, we have the potential to tear down the silos, speed up the building of data, reusable data that can be used not just for data warehouse using data warehouse automation, but produce the data to be used in other analytical workloads as well, whilst not having to repeat the data engineering again and again. And so companies can use automation technology to improve productivity. But if you get the architecture right and the design and adopt data products as well, potentially you can use this automation to produce data for multiple analytical workloads and like build once, reuse everywhere. So it's not just accelerating the development for data warehouse, it's potentially accelerating the development for multiple analytical workloads because of the fact that we're able to access these from multiple engines, including our data warehouses. So I hope that gives you an idea of what I think is potentially becoming possible here. And I think there's more to come, of course, with all of this. But certainly from what I've seen, like the announcement this morning, pushing Spark stored procedures into a data warehouse just gives you the ability to start running, Spark-based machine learning in the data warehouse, but on open tables. Why not? I mean, so potentially using the data from open tables. So to me, it's greater convergence as I start to see more and more of these models. Anyways, with that, I need to hand back to Brad and go to the next phase, and then hopefully we'll get to Q&A at the end of the session.
Great, thanks, Mike. Yes, I'm going to run through a quick demo of Wordscape for everybody, and then leave some time for the questions that we have. But I just want to give everybody an idea of what our tools are bringing to the table. This is not going to be an exhaustive demo by any means, because we only have a short time here. But if you would like to get learn more about the product, see a full demo, you can go to our website. We have a button there. You can click to request a demo, and we will get in touch with you. So Wordscape has two products: Wordscape Red, Wordscape 3D. We'll be looking at just Wordscape Red today. Red is our builder product, so it's the tool that you're going to use to actually build out your objects in your data warehouse. So whether that's, tables, open tables, views, whatever you need, Red's going to be generating the code and creating all that sorts of stuff for you. Wordscape 3D is our data discovery, profiling, and modeling tool, so it can be used to discover your source data, the physical layout of everything. It can be used to profile that data so you can better understand how the data relates to itself, and what exactly is stored in your source systems, and then automates the process of transforming those source systems into your downstream models. So whether that's a data vault, a star schema, an ODS, a lake/lake house type of structure, whatever you want, we can help you get to that from your source model to that target model faster than just doing it by hand. And so what we're looking at right here, this slide, this is our Wordscape Red overview slide. This kind of talks about what the tool is going to do for you at the higher level before we get into the demo itself. And up here at the top, this is your basic tried and true data flow diagram for when you're building out a warehouse. Showing your data coming from your sources, getting in your target system, going through transformations, finally winding up in your end user semantic layer, star schema, where your users can then get the data through BI tools or views or however they want to see it. And so what Wordscape is doing is automating everything from the red on the left here to the red on the right. So that starts with accessing your source data. So that can be reaching out to an actual source relational database, pulling the data in. It can be hitting files stored in S3 or ADLS. So, Parquet files, JSON, XML, whatever you have. It can be doing API calls. So if you have some sort of a SaaS system as one of your source systems and the data is only accessible through APIs, we can use those to pull the data wherever it is. First thing we do is grab that data and land it in your target environment. And then there's a lot of flexibility on how you want to do that. So if you want to, create an open table and actually ingest the data into that, you can do that. If you want to just have a table on top of your Parquet files, you can do that. The tool is very flexible. We're not prescriptive in any way telling you how you should do things. We just give you the tools to support however you want to do it, to support your automation. The tool is also extensible, so if there's things you want to do that we don't have quite out of the box, you can very easily extend the tool to bring in that sort of functionality. So once the data is landed in your target environment, we then generate all the code to create all the objects that you need. Again, all the different type of objects that your warehouse or your lake house is going to need. We generate all the code to move the data throughout those objects, and then we generate documentation over the top of everything. So we're automatically self-documenting for you, taking that step out of the process. The way we do this is through metadata, as Mike touched on in one of his slides. So every time you create an object for your warehouse, we're going to store the metadata about the object in here, table and column info. We're also going to store the information about your data flow process. So if you map table A to table B, we store that in there. Any calculations you set, we store that in there. Any other functionality or aspects of the tables types that you're creating, we're going to store that in there. And then we have templates in the tool written in a code called Pebble that run. They pull that metadata and then they use that to generate the code that's executed in your environment. So we're basically going to be generating Python scripts that connect out to your target, send it SQL, so execute within there, within your target database environment. Every target that we support has its own set of templates, and we support all the major databases out there. So your on-prem databases, SQL Server, Oracle, Teradata, Netezza, so forth, as well as all the cloud players. So Snowflake, Databricks, Synapse. We are currently diligently working on our Fabric offering, kind of refining our approach to that as Microsoft Fabric itself gets refined. But that lets us take advantage of any different functionalities or built-in efficiencies the different platforms bring to the table. So, the different type of open tables, depending on what platform you're using, or any different, built-in auto tuning, auto scaling, that sort of stuff we can leverage by using the different templates. And then the last point on there too is, as I mentioned, everything's happening in your target environment. So we're not going to be pulling the data out of your environment, running it through ours and pushing it back in. Everything's going to stay in your ecosystem. So number one, that helps with security issues, since we're not touching the data, we're not accessing the data, that helps alleviate a lot of security questions that come up. And then number two, again, that lets us take advantage of the whole reason that you're using something like a Databricks, is to use the functionality built in there rather than taking the data out to do something and then putting it back in. So, and then, yeah, like I mentioned, we also use that metadata to generate documentation that you can easily publish out. It's all HTML pages. So you can publish out through SharePoint or on your intranet or to a shared drive. You can automate the process of regenerating the documentation so it can refresh every night or as part of your deployment process, whatever you need to do. And then we also have a job scheduler built into the tool. So if you don't have an enterprise scheduler and you have jobs that you want to schedule, we can handle that as well. We can also integrate with enterprise schedulers without an issue. So that's a quick overview. And then now, quick look at the tool in action. Like I said, this is going to be very quick, just kind of whet your appetite for the big full-blown demo. But what we have here is Wordscape Red. On the left is our object browser. These are all the different object types we have automation for built into the tool. On the right is where we browse our source and target data. Middle top's where we do our results. Middle bottom's where we see our results. What I'm working in today is a Databricks target that's got a fact table and a few dimensions I've created out. My source will be an on-prem SQL server. And you can see we have all these different types of objects in here. So the first object type we have is a load table. That's basically going to be akin to your bronze layer if you're doing the medallion approach, where we're going to first get the data landed however you want it into your target database. And so to do that, like I said, I'm going to source from SQL Server here. The cool thing, like I said, we can source from all sorts of different places. So you can, if you need us to bring the data all the way from your on-prem source into your warehouse, we can do that. If you already have the data extracted from sources and loaded into Parquet files somewhere, we can hit those. If you've already got the data landed in your lakehouse, landed up in Databricks, we can start from there as well. So you don't have to go through this whole process. If you already got something set up that's working, you can keep using that when you bring in Wordscape. So yeah, so I browse over here to my source. You can see my tables and my views listed out here. And then to bring it in, all I need to do is drag and drop my source. We get a new object window that's going to add naming standards and things like that to the objects we're creating. And then we get our load options window here. This is just going to kind of set up how the data is getting put into your table. It's also going to determine the DDL that's used to generate this table that's reflecting the data. So again, you can control whether it's actually ingesting the data, whether it's just sitting on top of files, whatever you want to do. In this case, it's going to go out there and generate a Python script that's going to query our source table. It's going to pull that data out into a file. It's going to load that file up into Databricks, and then it's going to generate this table we see up here and load the data into there. So I'm actually ingesting the data, but it's creating a Delta Lake table by default. So it is creating the open table for us. And you can see up here the table it's creating has just got the columns from our source plus a couple extra metadata columns. And we can see here now it's loaded 92 records, which we expect based on the source count over here. We could go in here, we could look at the data, make sure everything looks okay. But so this has us on our journey. So now the data is up in here, it's in the open format. We can do whatever we want with it. Typically the next step will be to start, bringing data together from multiple tables, joining the data, filtering it, aggregating it, doing transformations. We do that via what we call a stage table. This, again, could be akin to your silver layer. And you can rename these. This is load table, stage table. You can rename them to bronze and silver if you like within the tool. We also have a couple of custom categories over here that you can use. So again, you can also rename those to bronze, silver, whatever you want. The process of creating the stage table is going to be very similar to creating the load table. We would just browse to our Databricks environment, find the table that we want to build off of, and then drag and drop. We already have one of those, so we'll create stage customers too. And again, it's going to go out there, build us a Python script to connect to your database and, and then generate and send SQL up there to move the data around as needed. As I mentioned, this is where you can add column level transformations. You could join multiple tables together. We take care of all that work behind the scenes for you. Once you have your data all staged the way you like it, then we have automation built in to push it out into your semantic layer. So whether you want to create views on top of everything, if you want to create your star schema, your dimensions, and your facts, we have automation built in to help you very easily quickly create your type 2 dimensions, pull together everything in your fact tables. You could of course put views on top of those as well to create an extra layer of extraction uh, abstraction, whatever you want to do. The last thing I want to show real quick is some of our data lineage capabilities in here. So that's one thing that's real nice. As you're getting rid of these silos and data's coming in one spot and then going out to many places, right? You're going to want to be able to track where the data is going, what it's doing in case, you make changes. As we saw again in one of Mike's slides, you're going to want to be able to track how those changes flow downstream. So we have different things in here. So for example, I could go and for this employees table, I can look at what we call our track forward diagram. And it's going to go and show me everywhere that data is going downstream. If there were multiple tables being fed by it, this would be a more exciting diagram, but this one's pretty straightforward. We can also do what we call our track back diagram. So if you want to know, what all tables are feeding into one of your target tables, you can easily look back and see where all of your data is coming through. You can go to these tables, see the properties, see what transformations they're doing. You can also track forward and track back at the column level. So we can track this company name column everywhere it's going, and you can see even if the column name changes somewhere in a table or view, we're able to track that as well. And all this data lineage is included as part of the automation that we document, the documentation that we automate automatically for you so that all of your users outside of the tool can easily understand where the data is coming from and where it's going to as well. And so that's all we really have time for today. As I mentioned, this is just kind of the tip of the iceberg of red. We didn't even get into 3D. So definitely, if this looks intriguing to you, go to the website, request a demo, and we will set something up for you. And so with that, Mike, we do have a couple of questions that I want to pop over to. So you could talk about these a little bit. First question says, I see that you're mentioning data fabric. What is the direction for this in the industry, and who are the major players?
Okay, so I think the general direction is that companies are struggling, I think, with a lot of um, with a lot of best of breed tools, and so they're trying to converge a little bit more and rationalize around common fabrics to connect to a broad range of data sources and be able to build the pipelines, and potentially even have multiple teams involved in doing that. I mean, clearly automation that we're seeing here, would be part of that fabric to accelerate the process of building, um, those pipelines in a more automated fashion rather than coding it or using some more drag and drop kind of tooling. But I think of course, there are major fabric vendors. Clearly vendors like well, all of the major cloud service providers, um, and of course, as I said, adding automation into that, with the likes of something like Wordscape is kind of where people are headed. But I mean, you know, clearly there are, um, you know, the Googles, the SAPs, the Oracles, the IBMs, Microsofts of the world, all have data fabric software, and there are other players as well. But clearly, in in this case, being able the reason why we get fabric, the term fabric, is because we're now living in a world of distributed data landscape, and the data is scattered across multiple clouds, on-premises data stores, the edge, and even software as a service applications. And so we need the ability to connect to all of it to be able to get the data, build the pipelines, produce the data products that we want, and then use them to support multiple analytical workloads. And I think so data fabric software has the ability to connect, but increasingly some of those vendors are also adding, full-blown governance into their fabric platforms. And but it's also becoming pretty clear though that fabric offerings are increasingly adopting open table formats in order to support and share data across multiple workloads. I mean, obviously, I can provide more detailed list of vendors if necessary, but it gives you an idea. I mean, the whole purpose of data fabric software is to provide a common platform to connect to all the broad range of data sources and allow both the um, definition and development of pipelines as well as governance potentially of the distributed data landscape that most organizations now have.
Okay, great. Thanks for that explanation. And then in our last couple minutes, one more question around automation, which reads, automation has an Achilles heel, and that is business rules. What tool, application, or language recommend?
um, well, automation vendors, we've already seen an example here of Wordscape as an automation vendor. Um, the business rules, if you mean metadata, nothing is going to magically generate all of your metadata. I mean, we are definitely seeing more and more ability to generate metadata through, for example, things like data catalogs and reverse engineering and that kind of thing to be able to discover what data you have, even to profile the data quality profile it to understand the quality of the source data. And by mapping, business, having a business glossary that I mentioned and mapping physical source data to your business glossary terms. And of course, I think Wordscape correct me if I'm wrong, Brad, but I think Wordscape has the capability to have its own business glossary. In fact, can even import business glossaries from other other vendor technologies. But if you know the glossary and you know the sources and you know the mappings, it kind of then says, okay, it's not that difficult to then generate the pipelines using automation to be able to um, produce the data needed. And in that case, most of the metadata is being automatically created as opposed to necessarily having to key absolutely everything in. So I think more and more as we start to adopt things like data catalogs and discovery and glossaries and whatnot, and being able to map sources to glossaries, define the data within our business glossaries that I talked about, it then becomes more and more capable of automating uh, uh, that without necessarily having to have you define all the rules. Of course, there's early signs of being able to define the rules in a more simple fashion if you have to do data quality validation, rule checking and whatnot, and we're definitely seeing I guess the emergence of something like generative AI to be able to add natural language data quality validation rules, for example, which can be converted into code. But you know, that's to simplify the user interface. But I think generally speaking, more and more automation is not just automating the build, but it's automating the generation of the metadata to allow you to do the build. So accelerating the whole thing from end to end.
Okay, great. Thank you for that explanation as well. And that brings us right here to the top of the hour. So we'll go ahead and wrap up. I just want to say thank you, everybody, for joining us today.